Now we'll start our today's session, ExpressPCB software. This software is very important to design the PCB layout for the electronic circuit. So before starting this ExpressPCB software, we'll study what is the meaning of PCB and what is it. So PCB, it is printed circuit board. All electronic circuits are manufactured on PCB. So if you see, this is the PCB, this is track side, and this is component side. This board is known as PCB, printed circuit board. So if you see, there are two types of two sides are there. So one is track side, so this is my track side, and this is my component side. So one is track side, other is component side. You have to mount component from component side, and you have to do the soldering from track side. Now ExpressPCB is used to draw this diagram. So this diagram is known as PCB layout. So in this session we are going to learn how to make PCB layout. So this is PCB which has two sides. One is track side and other is component side. Now why we are going for PCB? Take this simple circuit. This is IC555 monostable multi-vibrator circuit. If you do it on breadboard, it looks like this. So there are connections through wires. There is no base for the component, so there is chance of loose connection, and due to that your output will not get properly. But if you make this on printed circuit board, that is PCB, it looks like this. So there are no wires, all wires are replaced by this track. So there are less wires, there is mechanical support, so PCB is very important. Therefore we are going for PCB. So PCB has some advantages, like it provides mechanical support. There is no electrical wires are required to connect. Actual contact is through copper track, and therefore there is no chance of loose connection. And PCB occupies less space, and much time is saved in assembling the circuit. So these are the advantages of PCB. Now there are different types of PCBs. First type is single-sided PCB, which we are going to study. Second, double-sided PCB. At both sides there is copper track. Third, multi-layer PCB. It is used in computer. And fourth, flexible PCB. You have seen some keyboards are folding keyboards. In folding keyboards, flexible PCB is used. So these are four types of PCBs, and we are going to learn single-sided PCB design. Now we will see the PCB manufacturing steps. Your first step is circuit diagram. In previous video we had studied how to draw the circuit diagram. In this today's session we will see PCB layout and PCB artwork. So our today's work is PCB layout and PCB artwork. In next session, this is the PCB manufacturing process, pattern transfer, darkroom facility, developer tank, etching, cleaning, drilling, component mounting, soldering. So this is in next video. So in today's video we are going to learn this PCB layout and artwork. Now, so first step is circuit diagram. So we are using Proteus software to draw the circuit diagram, but we will take one simple circuit. This is IC555 monostable multivibrator, or we can take more simple circuits like simple circuit. This is one resistor and LED, and I want to make PCB layout for this. So for that, the layout will be like this. So this wire is replaced by copper track. All wires are replaced by copper track, and there is two holes to mount resistor R1, and there are two holes to mount LED, this LED. So this is the bottom view or track view of PCB. The component view is like this. So from top side you will observe only two holes for wire, 9 volt and 0, and these are two holes for resistor, and this is LED. So this is my bottom side and this is my top side. So this is the simple circuit. This is bottom view, this is top view. Take the another big circuit. So this is simple transistor switch circuit. So these wires are replaced by track, and you have to keep holes for component. So it is like this. So this switch is replaced, we have to put it here, or this resistor at here. This transistor has 3 terminals, so there are 3 holes. This is the LED, here you have to put LED. Resistor, here you have to put resistor. So this is the layout of this circuit. Now we'll take our circuit monostable multivibrator. So this is the layout of monostable multivibrator. In market there are some softwares which will draw the layout automatically. So this is the software which is used to draw the layout automatically. So I will give you demo also, the software which will draw the circuit automatically, which will draw the layout automatically. So this is our basic of PLC. Now we'll start our session. In the previous video we had designed this circuit in Proteus. Now we will design PCB layout for this circuit. So for that we are using ExpressPCB software. ExpressPCB software, it is free of cost. It is free of cost and it is available at expresspcb.com. Why we are not using PCB layout in Proteus? Because Proteus is not freely available, but ExpressPCB is freely available and it is user friendly, very simple software. Therefore we are using ExpressPCB. Now when you install ExpressPCB, you will get two options, ExpressSCH. So this is my ExpressSCH and ExpressPCB. So after installation you are getting two softwares, ExpressSCH, ExpressPCB. ExpressSCH is used to draw the circuit diagram. So this software is used to draw the circuit diagram, but you cannot simulate the circuit diagram. As in Proteus you can draw as well as test it, but in ExpressSCH you can only draw the circuit diagram, you cannot test it. In ExpressPCB you can draw the layout. So to draw the layout we are using ExpressPCB software. So in this video we are going to learn how to use ExpressPCB, this software. So first step, open the ExpressPCB software. The PCB layout diagram will appear like this. So this is my option. So here you have to click on help and then you have to go to quick start guide so that you will get all information. Then your next step, click on component and symbol manager and you will see the component names like this. So these are the list of component and this is the picture for component. So you will observe all components here. If you want to get new component you can use find option. So by using find option you can find easily and then you have to add into layout. After that insert following component for power supply. So component required for power supply are 3-pin connector for transformer, 4 diodes for rectifier, 2 capacitors for filter, 7805 for getting 5 volt, 790 for getting minus 5 volt, then 2 electrolytic capacitor at output, 2 resistors, 2 LEDs and 3-pin connector for output. So after that adding component it looks like this. So this is my 3-pin connector, 4 diodes, 7805, 7905, 2 filter capacitor, 2 output capacitor, resistor and LEDs. Now next step we have to arrange this, like left side is input, right side is output. So after that you have to arrange all the components and observe no component should touch to each other. So how to check whether these components are touching to each other or not? So for that colors are used. So yellow color represents silk screen, that is shape and size of the component, and red color represents the terminal. So if yellow color of components are touching to each other, then components are touching to each other. So please keep safe distance between yellow colors of component. So after that it looks like this. So this is my transformer connection, this is my bridge rectifier, then filter capacitor 7805, 7905, output capacitor, resistors, LEDs and output terminal. After that you have to connect these wires. So for that you have to click on track, select track width as 0.05 inch, connect the components as per circuit diagram, and the track color is green. We had seen 3 colors. First color is yellow which is shape of component, second color is red which is hole for that component, and green is track of the component. So in this is your hole, this is the shape and green is track. Now next step we have to write down the specifications of all each components. So you have to assign the part ID like D1, D2, D3, D4. You can write properties, and then you have to select bottom layer and you have to type the name, your name or PCB name. So after editing it looks like this. So this is transformer D1, D2, D3, D4, 1000 microfarad capacitor, 7805, 7905, 10 microfarad, 10 microfarad, 1 resistor, 1 resistor, LED, red LED, green LED, output capacitor, and here you can write your name or circuit name. So this layout is ready in computer. Now we have to take printout of this layout. So for that you have to click on file menu, then you have to select the print option and observe various options, and in that option you have to select print of bottom copper layer. So these are various options: top copper layer, bottom copper layer, silk layer. So I had selected bottom copper layer. So when I print, the view is like this. So only I am getting bottom layer, which we have to print on copper plate. If you want component layout, again click on the file menu, select print option, and from that you can select silk screen pads. So silk screen pads and text. So you will get this diagram. So this is the top view and previously was bottom view. So this software is theoretical part. Now we will go for practical part. So we will do this PCB layout in ExpressPCB. So in ExpressPCB you can draw only PCB layout. In ExpressSCH you can draw circuit diagram only. So we'll go for our software. So after installing you will get ExpressPCB and ExpressSCH. ExpressSCH is used to draw the circuit diagram. You can draw circuit diagram here, and ExpressPCB is used to draw the PCB layout. So we'll start our session to draw the PCB layout. So first you have to click on help, then Express Quick Start Guide, and in Express Quick Start Guide everything, all information regarding this software is given. So which button is used for which purpose, everything is given here. So this is my ExpressPCB help. Now we'll start our session. So first point, you have to add component. So you have to click on this component manager. So this is my component manager. So list of component is there. So I have to add component. So my first component is 3-pin connector. So I will click on C. C means connector, and here you will get different connectors. So I want 3-pin connector. So this is my 3-pin connector. Just click on insert component. So this is my first component. Then I want diode. So I will click on find and I will click diode. So this is my diode. Now I want 4 diodes. So I will click copy, paste, copy, paste, copy, paste. So these are my 4 diodes. After that I want filter capacitor. So I will click on C. C is capacitor. Now I want electrolytic capacitor. So this is electrolytic capacitor. Now important point is, in our circuit there are filter capacitor as well as output capacitor. The value of filter capacitor is 1000 microfarad and value of output capacitor is 10 microfarad. The distance between pins of 1000 microfarad capacitor is 5 mm, and the distance between output capacitor pins is 2.5 mm. So filter capacitor is big and output capacitor is small. So we have to take this 5 mm as output filter capacitor and 2.5 mm as output capacitor. So see the difference between shape. So this is output filter capacitor. I want 2, so I will select copy, paste, and this is my output capacitor. I want to use 2, so copy, paste. Now we want 7805, so I will click on 7805. So there are 2 options for 7805. This is first option, this is second option. So this option is with mounting hole, so you can fit it heat sink here, and this is without mounting hole. So we are using without mounting hole. So 7805 and 7905 layout for component is same, so I have taken this. Then we have to use resistor. So I will click on resistor. So this is my resistor. You can select the resistor according to your specification. So this is my resistor. Then I want LED. So I had taken LED. Now I want one resistor and one LED for positive power supply and one for negative power supply. So I had taken this component, and at output I want connector. So again one connector is there. So my first step is using component manager, add your required component. Now second step, we have to arrange this component as per your circuit diagram. So your first component is transformer. So my transformer is here. Then second component is my bridge rectifier. So this is my diode. Then again this is my diode. This is also my diode. After rectifier, our next component is filter. So this is my 1000 microfarad capacitor as a filter. Then you have to use 7805 regulator. So this is my 7805 regulator. This is my 7905 regulator. Then I want to use output capacitor. So this is my output capacitor. This is also my output capacitor. Then I have to use resistor and LED. Again resistor and LED. And this is my output connector. Okay, now we'll start our next step is to place trace. So I have to click on this place trace. Then you will get these three colors: yellow, red, green. For track you have to use green. So I will select green color. And this is the track width. So we have to select track width. Now I am explaining some rules for PCB designing. First, the drilling or hole should be at the end of trace. This is the main rule. The drill or hole should be at the end of trace. It should not on the trace, because if you drill on the trace and if that drill is big, your track will damage. So it should be at the end of trace. Then the track width for 1 ampere 1 mm track width, for 2 ampere 2 mm, for 3 ampere 3 mm, for 4 ampere 4 mm. So according to your ampere requirement you can change your track width. So we are using now 0.05 inch, which is equal to 2.5 mm. So this layout is for 2 ampere. So you have to select this layout. And third, try to avoid 90-degree angle. But for a low power supply you can use 90 degree also. So these are only three rules. First rule is drill or hole should be at the end of trace. Track width is as per your current requirement for 1 ampere 1 mm, 2 ampere 2 mm, and try to avoid 90-degree angle in the track. Okay, now I will draw the layout. So first you have to select your first point. So I am selecting this first point by clicking. Now second point is not selected yet. So select second point. So I had selected second point. Again it is continuing. So if you want to discontinue, right click. So right click to discontinue. Then second, you have to connect this as per your circuit diagram. Now see, this drill is on track. So if this drill becomes big, this track will damage. So in PCB rule, our main important rule is track should not be on the trace. So you have to remove this hole. From this trace. So for that I will use this option, disconnect trace. So I will disconnect from here and I will connect it here. Now if you check the holes, this hole is at the end of this trace, this hole is at the end of this trace, this hole is at the end of this trace. So similarly you have to connect the trace and take precaution, the hole should be at the end of trace. So as per the circuit diagram I am connecting the layout. These dots, white dots, are known as grid. Try to arrange the component on grid. In ExpressPCB, this is manual process. This is not automatic process. 7905 pin number 2 has input. Now this is known as artwork. We are showing our art to connect this layout. This is your output pin, pin number 3 as output. Here you are getting plus 5 volt. Here you are getting minus 5 volt. So I am drawing as per the circuit diagram. Now I am connecting this 5 volt. In ExpressPCB you can draw this diagram manually. The advantage of ExpressPCB is you can remove or you can minimize the jumpers. Jumpers means extra connecting wires. Jumper means extra connecting wires. So this ExpressPCB software you have to draw manually, and in manual you can check for the jumpers. So I am connecting this diagram. Now this is my transformer, this is my secondary upper line. I will connect to these diodes. This is my secondary second line. I have to connect this to this. Now this is middle terminal is ground. Middle terminal is ground, and I have to connect that middle terminal here. So for that I cannot connect like this, because if I connect like this, at this point it is shorted. So I have to use another option. So I can select like this. So you have to show your art to connect these wires. So I will save this file. Every time save this. So I will save this on desktop, and the name of file is internship PCB. Now I want to give the name. So just double click on the component, and here you can write down the name. So this is my transformer. You can select the direction of property. So this is my transformer. Then this is my D1. So I will select D1. Now D1, I want this vertical like this. So this is my D1. Then D2. Then D3. Then D4. So these are my diodes. Then I have to write down capacitor value. So 1000 microfarad. I want horizontal, 1000 microfarad. Then again 1000 microfarad. Then this is 7805. then this is 7905, then this is 10 microfarad, again this is 10 microfarad, this is 220 ohm, this is red LED, so you can give name as per requirement, red LED, again this is 220 ohm, then green LED, you can write name as per your requirement, horizontal, vertical, and then this is output. This is output. Now I want to write down the name of this circuit or anything, so you have to select here, you have to select this text. Here you can write down Cytronics power supply and click here. Now we are selected green color, so it will appear in reverse direction, mirror image. So here you can write it Cytronics power supply. If you select red, it looks like this, Cytronics power supply, but it should be on PCB, so you have to select green color. You can make it bold also from here. So this is my PCB layout. Now I'll save. I have to click on file, print. So if you select top, so this is top copper layer, print to PDF, so I will give print command. So top copper layer, so you will get we want bottom layer, so you have to select bottom layer and you have to print it. So if I give command to print, this will be converted into PDF file and you will observe the layout. Now most important, so it is asking where to save, so I will save it in desktop. So bottom layer. Here you have to use printer. Now the printer is compulsory laser printer. You cannot use other printer. So printer is laser printer. Now I'm teaching you, I'm telling you the business point of view for PCB. 1 centimeter square PCB designing cost near about 5 rupees. So if you see, this is near about 10 by 10. So the cost of this layout PCB is 10 by 10 means 100 centimeter square is equal to 100 into 5, 500 rupees. So if you are making PCB for business, then make PCB as big as possible. But if you are making PCB for yourself, make PCB layout as small as possible. So right now this is my PCB layout. I will make it small as possible. So see what I am doing. I have to arrange the component so that size will become small and no component should touch to each other. So yellow color should not touch to each other. So see what I am doing. So first I will move this part from this to this. See, yellow part is not touching to each other. Then this part up to this. You have to check yellow part as well as this green part also. Green part should not touch to each other because this is track. Otherwise your circuit will become short circuit. Then again you can remove this. Again you can move this. Now if you see, this capacitor and this diode are touching to each other, so you cannot do like this. So you have to keep distance between these. So again you have to shift this. So now This capacitor and diode is not touching to each other. This is okay. So I am reducing this so that the cost for production will reduce. These are names. So if names are touching to each other, no issue. This is my output. So see, I had make half of the our design. So cost will become half. Is there any option again to reduce the size? Just we have to check. You have to use your art to reduce the size of this capacitor, size of this PCB. So my PCB layout is up to this size. So this is my PCB layout. So again I can reduce the size like this. I will move it at upper side, one line. Then I can put this below here. Again I can move this here. So again you can reduce the size. So you have to check how to reduce the size of layout. So this is my actual layout now, which is the half of our previous design. So this is the procedure to design the layout. In market there are some softwares, like this is one software, PCB Wizard. In this you have to draw the circuit diagram. So take example of this circuit diagram. I will open one circuit diagram, which is microcontroller board power supply. So 89551 board circuit diagram. So this is my circuit diagram, and we have done this rectifier, filter, regulator, power supply. I want to make the layout of this. So in ExpressPCB there is ready-made layout design. So just click on tools, convert design into PCB. No PCB will specify the design. Click on next and click on convert. Automatically component will be placed. There is no need to place trace. Automatic, everything is automatic, and within less than 1 minute you will get the layout of this circuit diagram. So this software is this software is PCB Wizard. PCB Wizard is used to draw the layout automatically, whereas ExpressPCB is used to draw the layout manually. So PCB Wizard draws automatically. So it is checking the tracks. It is checking the tracks, and within 1 minute your layout is ready. So if you see, it is real world layout, and this is the artwork. So within 1 minute your artwork is ready. So this artwork is ready in PCB Wizard. So in this, the disadvantage is jumpers. If you observe, there are blue lines, blue wires. So these blue wires are nothing but jumpers. You have to connect extra wires on PCB. But in ExpressPCB, no need to connect extra wire, because we are making it manually. We are taking precaution for jumpers, because this is manual process. So ExpressPCB is good to draw the PCB layout. So this is our today's session. So thanks for watching.